So an ellipse is a set of all points in which the sum of the distances, I know it sounds kind of weird saying that as a plural noun, the sum of the distances from two fixed points is a constant. So what does that really mean graphically speaking? So say I do my coordinate plane here, and let's say I have like two fixed points.
Okay.
And I'll kind of draw an oval around this. That's the center.
Okay.
So I'll call this F1, call this F2.
Okay.
I'll call this D1. I'll call this D2. D1 plus D2 will always equal the same thing, where F1 and F2 don't move. But if I take any point on the ellipse and measure that distance to F1 and also measure this as F2 and add up those two segments, they'll always equal the same number, regardless of wherever I am on the ellipse.
Okay.
Doesn't matter. Those two fixed points are called the foci, which is plural for focus.
Oh, okay.
Okay. So it's plural for focus. Um, so anyhow, um, that's what's going on there. So there's a form that goes with it. I can show you the formal derivation of it. It's pretty intense. For a circle, it's pretty easy. It's just, the distance form from the point of the
Yeah,
circle to the
that, yeah.
center, and you just stumble upon the equation of the circle. I'll just tell you what it is here. For an ellipse, the formula um, and there are two ways of writing it.
Okay.
And the major axis would be horizontal. I'll explain what that means in a moment. The vertices would be, I'm trying to think here, H, I'll say, the H plus or minus A, comma K. And here would be, so what this means is that, let's say my center of the ellipse is here,
Okay.
and I draw it like this. Then see how it's longer horizontally than it is vertically?
Uh-huh.
So this is called A, the distance from the center to the vertex. And you have two vertices on the left and the right side. The center we call H comma K like we did for a circle. And then B would be the length, it makes up the vertical axis. is the distance from the center to the top or bottom. So that's what we do k plus minus b. So we call the major axis, the length of the major axis will be 2a,
Okay.
length, and length
Okay, I see.
of minor axis 2b.
Oh, okay.
Minor because it's smaller. Um, the foci, just to add a little more to this, we'll call it this F2 and F1. The distance between the center and any of the foci is called C. So the foci would be H plus or minus C comma K. And C is determined as a kind of a fancy derivation, which I won't get into with you, but it's going to be C squared equals A squared minus B squared.
Okay.
Now, what if the what if the major axis is vertical? Then you just reverse, you reverse everything.
Okay.
So let me show you this one formula sheet that might be better. I taught this last year in pre-calculus, and I'll send it your way because I think this formula sheet will help you.
Okay.
Let's see, pre-calculus. It's the last topic we covered. Yes, no, oh no, it's probably right 4. Nope, maybe it's unit 1. Nope, maybe it was unit 6. Nope, it better be this one. I don't know where it is. The heck? No, we covered it. Well, maybe it's this year. Yes, okay, there we go.
Okay.
Yeah. So yeah, so here's the ellipse, right? So as I said, x minus h squared plus y minus k squared. You start x minus a squared of a squared plus y minus k squared b squared equals 1, where a is larger than b. Center is h comma k. The vertices is h, you move a left, a right. Co-vertices are the endpoints of the minor axis. And then the foci of that, and you have a diagram that helps you out. And the major axis 2a, minor axis 2b, c squared equals a squared minus b squared, or it reverses if the major axis is vertical instead. So this is a great reference sheet. Um, so now let's actually do some problems with that. Now you've seen this, and then I could talk about um, hyperbolas after that. So take a look at number 2 here, right? They say write the equation of ellipse as a vertex of 0, comma 4.
Okay.
Co-vertex -3, comma 0. And the center at 0, 0. So it means that the other vertex is 4 down. To the co-vertex is 3 right. So it kind of looks like this. So we're going 4 up, 4 down, 3 left, 3 right. The center's at 0, 0. So you're going to have h and k is 0, 0. And because we're going 3 left, 3 right, you're going to do 3 squared in the bottom, it's 9. And that's going to be 16 equals 1. And
Okay.
Okay. Here at the foci,
Okay.
okay. So c squared equals a squared minus b squared.
Okay.
So b squared's got to be 48. So you're using that formula that involves foci. So it's called analytical geometry because you're obviously being more analytical. Starts at 0, 0. So h and k is 0, 0. So you have x squared over a squared, which is 64. Because you're going left and right 8 and 8, up and down whatever that is. So y squared over 48 equals 1. You can always use Desmos to verify this too.
Okay.
Um, they can get a little more challenging, so I'm going to show you a more challenging one right now. Uh, and actually, I think I'm going to send you tests on this so you get some practice. Okay. Um, shoot, where did I go? Yes. Okay. Probably a better problem than this. Uh, actually, let's go here. There we go. I got better problems. I know I do.
Okay.
Sweet. Okay. So let's take a look at like number 7. So the ellipse is at negative 3, 4, and 5, 4. So now the center is going to be obviously not at 0, 0 anymore.
Uh, hmm.
Negative 3, 4 is right here. 5, 4. So if those are the endpoints of the major axis, what would be halfway between them?
Halfway between those, I mean, it's that. So it's x equals 1.
Yeah, 1, 1, 4. That's my center. My foci are negative 1, 4, and 3, 4. So remember the distance between the center and the foci is called c. So c is 2. And the distance between, excuse me, the distance between the center and the vertex, of course, is a, and a is 4. So if I work
Okay.
it out, c squared equals a squared minus b squared. 4 equals 16 minus b squared. B squared would be 12. And the center is at 1, 4, so you can write the equation as x plus 1, x minus 1 squared over 16 plus y minus 4 squared
Okay.
over um, 12 equals 1. And then this is the last thing we'll do with ellipses. I'll briefly talk about hyperbolas. Then we'll end our call for today. So if I look at like number 2, see, I could rearrange like this. X squared negative 10x plus 4y squared.
Okay.
Take half negative 10 squared is 25. But here you gotta be a little careful. You gotta pull out the 4 first. Then take half of 4 and square it, which is 4. But really what you're introducing is 16. So you have to add 25 and 16 to this side.
Okay.
Because if you shoot the 4, you do get 16. So when I work it out, I get x minus 5 squared plus 4 parentheses y plus 2 squared equals 4. Divide everything by 4.
Okay.
So the center is 5, comma negative 2. You go 2 left, 2 right. You go 1 up, 1 down. You do the, do a quick sketch. 1, 2, 3, 4, 5. 1, 2. Go 2 left, 2 right. 1 up, 1 down. Boom, boom, boom. There you go.
Okay.
So that's I'm guessing what you're going to be seeing for this topic that you'll be doing tomorrow in class. And then for for hyperbola looks like this.
Oh,
It's, it's
I don't think. Wait.
you will be doing it on Friday. It's in your calendar.
Oh, okay.
So what's happening here is that I said the sum of two distances was a fixed point, or sorry, that was a constant for an ellipse. The difference of this distance between two fixed points. So if I were to let me go back to a blank screen, that might help.
Okay.
If I pick two fixed points here, and I'm going to draw something like this here. And if I pick a random point over here, draw that and draw that, calls D1 and D2, and take the difference between them, D1 minus D2 will be a constant. Okay, D1 minus D2 will be a constant.
Okay.
That's what's happening there. And we still call F1 and F2. The formula looks like this. Now I'll just kind of show the formula. It's similar to the ellipse. There's a minus and a plus in the middle. And whichever fraction is positive, the hyperbola opens in that direction. So if x square is positive, then it's all going left and right. Y squared is positive, going up, down. And A is the difference from the center to the and vertices. And B, so we do a central rectangle. And the distance from the center to the top of the box or bottom of the box would be, or if it's reversed, then it'd be to the left and to the right. Um, you have asymptotes that are the diagonals of the box, and that's going to be the slopes when you look at B over A over B, whatever we're doing. So yeah, that's what's happening there. Um,
Okay.
yeah, and that's pretty much it. So hopefully it makes sense. That this is the stuff you'll be working through. But let me go ahead and email this stuff to you. Let me stop my recording.